Page 14, okay? These are actually, if you practice, these are actually pretty straightforward, right? Like you just like apply, 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 follow through, solve, right? So it's no word problem. Isn't that nice? No word problem. Okay, so regardless of what's happening here, always focus on the polygon outside. Like count the sides. And we counted that this had 7 sides. And A happens to be my interior angle. So I can just go ahead and say that A is going to be 7 minus 2 times 180 divided by 7. I don't have the answer key in front of me. That's 128.57 degrees. Okay? A, you got the mark there, no problem. One thing that I want you to know is that if this is B, is it fair to say that this should be called B as well? Okay, so you can feel free to do that. I will probably purposely put it somewhere else so you don't, like, you have to think, right? And so, why are you being so mean, right? 360, this is now, I'm talking about this 4-sided shape, right? That's a trapezoid. So it's a 4-sided, so 360 minus whatever A is, which is 128. I did give you the 2 times, right? That's what I did, yeah. The formula I gave you is 2 times 128.57 because you have 2 of those interior angles of the heptagon as part of your trapezoid. Does that make sense? Right? So we go ahead and find out what that is. That's 102.86 divided by 2, 51.43 is that. So we got our B, we got A. Should you tackle D right away? Does that look like a shape I talked about? It doesn't, right? It's weird. It's a weird looking. We're gonna leave that, and now we're gonna focus on this one, which is, right, it uses 2 of the sides of this heptagon, right? And this is one interior angle. So I'm gonna use this triangle, knowing that it's an isosceles triangle. So for C, I'm gonna go 180 because this triangle has 180 all 3 angles combined. So 180 minus one of those interior angles, right? This one is 128.57 divided by 2. That's 25.72 degrees. Sorry, can't see that. So I got A, B, and C. Now I'm going, and these could be X, Y, Z, right? It doesn't, the letters shouldn't matter too much. Now I'm going to focus on finding this one because, and notice that all 3 are adjacent to this interior angle here. So to get D, I'm just gonna take the 128.57, which is all of this, subtract B, and then subtract C, and that remainder is gonna give me this. Okay, that's my strategy here. So to get D, I'm just gonna go I minus the one to the left minus the one to the right. So this is probably a little bit different than the key, and that's all right. Minus B minus C. Watch this, it's very close to the other one. But it's not quite. Okay. You want me to do the second one? Okay. So I'm going back up. I focus on the outside, right? So 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8 here. You can do whatever, like you can choose to deal with this one first. And then, oh, shading. Don't you love that? Do you remember that? You can do this pentagon or you can do the trapezoid. It's up to you what you want to do first. But focus on the outside, like that shape making, right? The diagonal creates something with the actual octagon. And then this diagonal creates a trapezoid with the outside, right? So I'm going to choose to start here. So trapezoid, how's that? A is actually the interior angle of the octagon, right? Which is, okay, 8 minus 2 times 180 divided by 8. Is that 135? It is 135, right? So you just found the interior angle of the octagon, which is 135, and it just happens that A is that, right? If this is C, then this is C also, right? Make no mistake, they're the same. It's an isosceles trapezoid. So to find C, it's going to be 360 minus 2 times the interior angles, and the remainder you will split in half. So you take 360 for the trapezoid, take away 2 of those interior angles that are up here, right? 135, 135, take that away, and then split it in half. So it's 360 minus 270, basically there, right? Divided by 2, that's 45 degrees. You just have to be very careful to do the top first, and then divide by 2. So you've got that taken care of. Now I'm going to focus on the pentagon, which is this one here. I might do arrow. I'm trying to get creative here to make you see it, right? And by the way, if you have a different color, what time is it? We have time. This is A, this is A, and this is A, right? Technically, all the interior angles all around would all be A, right? So if you find it, it's just showing up there, but really it's on every corner of this shape. It's the same angle. So we have 3 interior angles to subtract in this case. And if this is B, we know that this is B as well. Just like we knew this is C here, because that was C. So now I'm going to go and actually do the math, right? So to find B, I'm going to go 540. Why? Because that's the sum of interior angles of a pentagon minus 3 of the 135s, all of that divided by 2. 40 minus 3 times 135 divided by 2, that's 67.5. And to find angle D, what I'm going to do is I'm going to take the interior angle and I'm going to subtract C from it, and I will also subtract B from it. So it's 135 minus 45 minus 67.5. Which is 22.5. I found them all. We're good? Is this painful or what? The key on this was out as well, and really it's all done the same way. Maybe what I will highlight here is that this here, this is an exterior angle. And so is this one. You see it? Like, remember when you travel, like if you think of this hexagon here, if you travel along the hexagon and then all of a sudden you extend it, right? That's your exterior angle. Same if you come from this side and you extend it, that's also an exterior angle. Wouldn't it stand to reason that this exterior angle should be the same as that one if it's a regular, right? So what kind of a triangle do you have here? I think it ends up being equilateral in this case. Let me see. 120, 60. Yeah, this one ends up being equilateral, but not always. You got to watch out. It depends on what this angle is, right? A hexagon, that's one of the unique properties. It's actually 6 equilateral triangles put together. Only the hexagon is. Don't worry about that too much. Maybe don't let that throw you off. If you went over this, I will just mention this one. Maybe you have to read very carefully. Does it mention exterior or interior angles? What is it saying? Okay, saying that 3 exterior angles of a convex polygon measure 70, 60, and 90, and emphasis on the exterior. And we know it's a pentagon, so that's probably right. That means that there would be 5 exterior angles. The other 2 exterior angles are congruent. Determine the measures of the interior angles of that pentagon. So this is actually a very tricky question, right? So what you need to do is, first of all, find the other 2 exterior angles. 2 congruent exterior angles. What do the exterior angles always add up to? 360, always. Regular, irregular, doesn't matter. So we're gonna go, we're gonna call it angle A, or E. Let's use E. The exterior angles would be found by going 360. Sorry. No, wait. Yeah, we would go 360 minus 70, minus 60, minus 90. So you take the 3 that you know, and we will divide this by 2. Exactly. My key might be slightly different, but that's the idea. So 360 minus 70, so minus 60 is 300, so 230, 140 divided by 2. So it's 140 divided by 2, which is 70 each, right? Each of the congruent exterior angles that remain have to be 70 each to get the 360. So now you have a bunch of exterior angles and their corresponding interior. So let's make a bit of a table. We have a 70, a 60, a 90, and two. We actually have 3 70s then. Okay. So this has a 110. You remember they add up to 180, right? Okay, just making sure. So all they want you to do is state all the interior angles of this thing. So this is what they want. State all the interior. So there was a lot of stuff that had to happen before you even got to the interior angles. So we know this is not regular. It's not a regular polygon. Okay, the other thing that I wanted to go over is, you know, when I ask you to show whether or not things are parallel, when it's a triangle or a pentagon and stuff like that, I would like you to have at least one or two more examples of that. So this goes back to your notes then. Let's see. Strong. If you're against it, you come and talk to me. I'll tell you it's Friday. Anyways. Here we go. So that means I can cover one more thing tomorrow. It would be if it's. There we go. Graph your nicest pentagon ever. And then we're going to have a line across like this. And we're going to call that line AB. And this is going to be line CD. So when it says proof, you have to kind of go through, you have to make your case, right? And you do it by actually calculating some angles, by stating some properties that you know, right? And so you kind of build your case, and then you make a conclusion that they are in fact parallel. Keep in mind, remember those 4 angles, right? The corresponding consecutive interior, alternate exterior, alternate interior. You want to find those, any one of those 4, and prove that they are either congruent or supplementary, whatever pertains, right? And so what do you think would be a good first step here? Are there any numbers on here right now? No numbers on here, right? So what should we start with? How could you get a number in there? The interior angle of the pentagon, that's right. So n is equal to 5. We're going to go find that. And that's 108, right? So what we're going to do here is say that angle C is therefore 108 degrees. Can we say that? Yeah, you can say that because C is just, it's the whole angle. So you can actually just use a one letter notation there for that angle. Okay. And what else could we do here? We could find, I will call this X here. I'm going to find angle X. If this is X, then what is this over here? Also X, right? What's this up here? 108, right? So X is going to be 180 minus 108 divided by 2. And that is 72 divided by 2 is 36 degrees. So remember, there's a triangle here, and that's why I'm using this formula to get the 36. I'm going to write it in here. This is 36. This is 108. Is there a name for those two angles right now? Because we're getting close to it. Is there a name for these two? It looks like corresponding, but are they? They're not because of this line here, right? If it had kept on going like this, then this whole thing would have been corresponding to that one. This doesn't look like they're equal anyways, right? So can we find this one here, y? Yeah, y would be interior minus x. So y would be 108 minus 36. What does that equal to? 72. Is there, do we have a name for these two? Consecutive interior, right? You should see these are two lines, and this is a transversal. So we can go angle C plus angle Y is equal to 180, and our consecutive interior, sorry, I'm going to move this up. This is important. You're saying that they are supplementary or 180, and you give the name, and you're saying, hey, they are called this, and they are actually fulfilling that property. Therefore, AB is parallel to CD. And wait, there's more. If you want to review for the test, there's a test review at the back of this chapter test. There's some multiple choice there, which may or may not look like the one on the test. Page 36 to 39. One more thing. If you see anything, listen carefully. If you see anything on this test that is on here that talks about tessellations, don't do it. You can't do it yet. It's easy, but don't do it. Tessellations, tiling, anything like that, don't do it.